Someone has asked me to discuss my Thakur's. His idea of religion is firmly established on the foundations of science, mathematics, logic, and the universal tune. What my Thakur used to say was that আমার ধর্ম বিজ্ঞান ভিত্তিক, গণিত ভিত্তিক, যুক্তি ভিত্তিক এবং সুর ভিত্তিক. Okay, understood? Now, here, what my Thakur understands as science is quite understandable by all of you present here. It is the systematic study of the structure and behavior of both the physical and natural worlds through the means of observation, experimentation, and testing scientific theories against the evidence we have obtained. Understood? This is what is we know as science. If my Thakur is asked, then this surely will be his definition of science. So, today I am not going to discuss the scientific aspect of my Thakur's idea of religion because it is obvious and perceptible. For today's discussion, I also don't want to bring the concept of my Thakur's Shurovittik idea, the concept of the universal tune, because this concept to me is the most profound among all the four concepts of Dharma, Bigyan, Gonit and Shur, and thus deserves a more elaborate and deep discussion which we may do at some other time. Understood? Okay. Today I want to concentrate only on the concepts of Gonit and Jukti among the four, and let's see what my Thakur means by the ideas of Gonit and Jukti and how the philosophers and the scientists comprehend the concepts of mathematics and logic. In order to go into the depths of mathematics, you may like to start with Plato, the Greek philosopher from the 5th century BC. Plato is undoubtedly one of the most influential luminaries the world of Western philosophy has ever seen. He was a student of the great Socrates and also teacher to Aristotle. It is said that at the gate of Plato's academy it was written that no one should enter the gate who knows no geometry. Look, even during that ancient period, it was geometry and not arithmetic which was regarded as a more foundational and superior branch of mathematics. Now, mathematics provides a model of knowledge of a particular superior kind. Philosophers since the ancient Greeks for over 2000 years have regarded mathematics as very special, and mathematical knowledge has been regarded as something to which all knowledge could possibly aspire. Now, what makes mathematical knowledge so special? Unlike other knowledge, mathematical knowledge is certain. If something is true in mathematics and if you know it, you are never going to doubt it. You know that 3 plus 4 is 7, and you know this fact with absolute certainty. Another important aspect about mathematical knowledge is that it is incorrigible, which means it is not going to be corrected by anything you might subsequently learn. Understood? Another crucial element of mathematical knowledge is that it seems at the first glance to be both space and time independent. 3 plus 4 makes 7 on this planet and even in the most distant corners of our perceptible universe. Similarly, 3 plus 4, 7 was true 10,000 years ago or at the beginning of time, and in the distant future, even if there remains no humans on earth, it will still be the case. So, mathematical knowledge is certain, mathematical knowledge is incorrigible, and it's eternal. It is always true. Understood? Another defining aspect about mathematical knowledge is that mathematical truths seem to be not just contingently true, but also necessarily true. Here Bharati is wearing an orange robe. This doesn't need to be necessary. Bharati could have also put on something in green or blue or anything else. So this isn't a necessary truth. But 3 plus 4 could not equal anything but 7. It's necessarily equal to 7. Philosophers, from the ancient to the medieval up to the modern ones, have looked into these aspects of mathematical knowledge and have wondered what it is about mathematics that gives mathematical knowledge these special characteristics. We have found philosophers like Plato, Hobbes, Russell, who have wondered why can't other kinds of knowledge be like mathematical knowledge. Now, you may want to know whether my Thakur also sees mathematics in the fashion which I have just described. Yes, it's sure that my Thakur is in absolute agreement with all the commentary with regard to mathematical knowledge I have put forward now. So far, so good. Okay? But when we delve deeper into the concept of philosophy, into the concept or philosophy of logic, or more precisely, we start combining the ideas of Ganit Bhittik and Jukti Bhittik, that is to say mathematics and logic from the point of view of mainly Western philosophers, things start taking a different trajectory. So, here what is important from my Thakur's perspective is that even though he accepts mathematics and logic from the Western philosophical perspective, yet he has his own fundamental thoughts and understanding of the creation, and here in my Thakur's ideas, consciousness and free will play the most significant role in helping us what my Thakur actually wanted to speak about. I will come to that later. Now, the deepest puzzle about mathematics which has bothered philosophers for the last 2,500 years or so is what is mathematics about. If you add 3 mangoes and 4 mangoes, it gives you the result of 7 mangoes. Here 3 and 4 are about mangoes. But if you only consider 3 plus 4, which results in 7, then these are not about things but about numbers. Now, what are numbers actually? This is a deep philosophical question, and the more you think about it, the less clear it gets. Numbers seem to be the content of objective truth. When I say that 3 plus 4 makes 7, it is objectively true. We can obtain objective truths only about objects. So thinking along this line, can we say that numbers are objects? But unlike other objects, like say this mobile phone in front of me, you can't see numbers. They don't occupy space or reflect light in the way other objects do. You can't smell or taste a number, and so numbers are beyond the scope of our sensory experiences. So even if we try to conceive numbers as objects, they are a peculiar kind of objects which don't exist in space and time. They don't corrode or get old, and it makes no sense to ask what is the physical size of a number. It's not a part of our spatio-temporal world. Numbers are not a part of the space-time continuum. In order to counter this problem about numbers, Plato suggested the theory of forms, and these forms are abstract, objectively existing objects. Understood? This idea of forms confirmed Plato in his opinion that reality is formal and our spatio-temporal world is just a shadow of that absolute reality. Now, doesn't it sound like Shankaracharya's Advaita Vedanta views of Parambrahma and Maya? Doesn't it? Okay. According to Plato, this is why everything we see, smell, taste, touch, the knowledge that we get out of our senses is always open to revision and correction. We might look again, we might look twice and see something different, whereas formal knowledge, like the knowledge of mathematics, is always certain, and that's where, according to Plato, lies the superiority of our faculty of reason over the faculty of our senses. This is an extremely important feature of mathematical knowledge, and whenever you try to understand my Thakur's ideas, this aspect of certainty of reason over senses must be there. That's why my Thakur emphasizes so strictly for religion to be grounded firmly on the pillars of mathematics and logic. Is to say, amar dharma gonit bhittik, jukti bhittik. Understood? Okay. We can't see forms or touch forms, but we can grasp them intellectually. So mathematical truth is necessarily true. It's not contingently true, because it's not about the contingent world or spatio-temporal world. Now the problem here is how we bridge the wide gulf between the two worlds, the world of forms and the world of space and time, of which we are a part. This is the reason Plato's student Aristotle had a different idea about the world of forms. This concept of seeing numbers as forms brings to my mind another great German mathematician philosopher whose name is Gottlob Frege. He said that things depend upon how we conceptualize them. If you look at a chessboard, at the first glance you will see that there are 8 columns and 8 rows, and so there are 1 into 164 squares. But a detailed look will suggest that there are a total number of 204 squares when you take into consideration all the combinations of squares. If you see 8 rows and 8 columns, it is 64. If it is 7 rows and 7 columns, there are 49 squares. If there are 6 rows and 6 columns, there are 36 squares. If you take into consideration 5 rows and 5 columns, there are 25 squares. If you take into consideration 4 rows and 4 columns, it is 16. If it is 3 rows and 3 columns, it is 9. If it is 2 rows and 2 columns, there are 4 squares. And if you take the entire chessboard, it is 1 square. Adding this up, 64 plus 49 plus 36 plus 25 plus 16 plus 9 plus 4 plus 1 gives a total of 204 squares. Now, depending on how we are looking at the chessboard in terms of rows and columns, different numbers will belong to that particular collection of squares. Does this collection have the property 64 when we take into account 8 rows or 8 columns? Or does this collection have the property of 25 when we are taking into consideration 5 rows and 5 columns? Another example is a pair of shoes. When we are looking at from the perspective of the pair, it is a pair of shoes. But when we are taking into account the number of shoes, there are 2 shoes. So as a physical object, which number we are going to attach to it? 1 or 2? Understood? The pair of shoes? When you say a pair of shoes, it's 1. When you say only shoes, there are 2 shoes. Here, Gottlob Frege suggests that objects, objectively so to speak, do not have numbers as properties, but they acquire numbers as properties when we think of them in a different way. Now, if we do justice to the objectivity of mathematics, like Plato, we seem to be stumbling upon metaphysics of abstract objects, and we start asking deeply questions about what these abstract objects actually are and what they actually mean. Here, my Thakur will have no problem, as whenever something is given a name, it assumes a form in the physical world or in the metaphysical world or in the transcendental world. Now, in order to dive deeper into the philosophy of mathematics, I have to go to the towering 18th century philosopher Immanuel Kant. Immanuel Kant's thinking about mathematics is that when something is true mathematically, it is necessarily true. Kant's question about mathematics starts with the statement that how can we know something about the world which is necessarily true? Understood? This was what Kant asked. So he introduced 2 distinctions, a priori and a posteriori. Something is a priori if our knowledge of it is prior to any experience, any observation, any testing. But a posteriori knowledge requires observation and experimentation to reach at their conclusions. You almost know that Kant wrote 3 massive books, The Critique of Pure Reason, The Critique of Practical Reason, and The Critique of Judgment, and he wrote them in that order. Now, if you delve deeper into the philosophy of Kant, you will perceive that the basic philosophical project is to concern yourself with truth, goodness, and beauty. These truths, goodness, and beauty are the big 3. The most important ones. Critique of Pure Reason tries to deal with the issue of truth. Critique of Practical Reason tries to deal fundamentally with the issue of goodness. And the Critique of Judgment attempts to handle the idea of beauty or aesthetics. Understood? Now, if you go through Kant's critique of pure reason, you will see that what Immanuel Kant suggests is that what exactly can reason know and what can reason not know. Understood? Kant's argument is that at a fundamental level, reason is not able to know the things that philosophers perceive as the most important things about the world. What we call the world through our commonsensical faculty is not in fact the real world. This world, as we call it, is the world perceived by our senses, and it is just a construct made by subconscious or even unconscious structural factors of which we are unaware, and these factors create this world for our mind's attention. But it is what Kant calls the phenomenal world, and it is to be distinguished from the real world, which Kant describes as the noumenal world. Kant's argument is that, in principle, it's not just difficult to get from the phenomenal world that we are observing, it is impossible for us to get from the sensory phenomenal world to the ultimate reality or the noumenal world. Behind these arguments is a whole battery of very sophisticated skeptical arguments developed by Kant himself and also his predecessors, and all these sophisticated arguments conclude that we are actually cut off from reality or cut off from knowing reality. Okay? Here reason is a subjective capacity and it knows only a subjectively created reality, and it has no objectivity to it and no capacity for knowing real or actual reality. Here Kant suggests that we cannot know if the reality perceived by us is governed by cause and effect, or if it's a matter of miracles or some sort of chaos out there, and ultimately this postulate suggests that we can never know whether we can have a free will or not, and you must have realized by now that free will is absolutely necessary for us to be moral agents. Isn't it? Look, we cannot be moral agents if we don't control the choices we make. Now, if you turn towards my Thakur, the two most fundamental pillars of his ideas are those of free will, which my Thakur describes as Ichha Shakti, and the other rudimentary pillar is Vivek, which is concerned with the concept of moral agent. Kant thought that there's a prima facie conflict or inconsistency there between the physical world and the moral world. The central and simplest form of the conflict was that it seemed to be a presupposition of the physical sciences that everything that happens in the physical world is determined by antecedent happenings, and there's always a law on the basis of which one can say that what happened was the only thing that could have happened in the physical world. But we, also a product of the physical world, when we are thinking about our own conduct, when we are thinking, say, about moral predicaments, we may find ourselves in those which we believe that we and everybody else have alternatives before us, and there are various things we could do, and for that reason we have to accept the responsibility for what we actually do. Kant asked that how in a universe in which the motions of all matter are governed by Newtonian laws of science, then how can there be free will for humans or other life forms? Here space is an inbuilt category of our subconscious mind, and whatever comes in from external reality, it goes through our senses, gets filtered, and ultimately gets constructed into a spatial reality, and the same idea goes for time and also things in cause and effect relations, for they are also subjective categories that are added to it. So all this rational concern with getting the spatial and temporal proportions right devalues you to someone who is very good at studying the subjective phenomenal world, but what's reality or what is actually out there, you are missing all of that. Here Kant suggests intersubjectivity or a universal subjectivity. Well, this is a property that holds for an entire category or a whole class, and the term he suggests is subjective universalism. You in your own subjectivity and I in my own subjectivity, and because we have the same universal constituting factors, we can be intersubjective, or there's a universal subjectivity. Understood? But this idea of Kant was later challenged by next generation philosophers like Hegel and Marx or even Nietzsche. So the idea from the next generation philosophers was that there are different subjectivities out there, and those subjectivities cannot be translated right across. So maybe different economic classes have different subjectivities, and that's the version of Marx on Kant's idea. Or maybe the constituting factors evolve across generations, and that's the idea of Hegel's evolutionary move. My Thakur, on the other hand, sees the jeev or the organic creatures not only as an integral part of the creation, but according to my Thakur, jeevs or the life forms are the seeds of the universe, and on this count my Thakur's idea differs from all the three major branches of Vedic philosophy, the Advaitavad, the Vishishtadvaitavad and the Dvaitavad. The Dvaitavad of Madhavacharya subscribes to the idea of two distinct absolute realities, the reality of God and the reality of the world. The Vishishtadvaitavad or the qualitative non-dualism of Ramanujacharya sees the jeev as a part of the God which pervades the entire cosmic design. And according to the Advaitavad of Shankaracharya, there's only one reality, and we are cut off from the absolute reality through our ignorance, which he calls Maya. But my Thakur sees the organic creatures as the seeds of the entire creation, who have the capacity to not only emulate the mother creation in size and stature, but also to surpass it. Now, returning back to the idea of mathematics, according to Kant, we don't get mathematics from the world, but we bring it to the world. That's why mathematics can be divided into two parts, geometry and arithmetic. Geometry is the spatial form through which we see the world, and the world appears to us to be three-dimensional, the Euclidean three-dimensional space, which we call the Euclidean three-dimensional space. Just as geometry is the form of our spatial awareness and spatial intuitions, arithmetic, on the other hand, is the form of our temporal intuitions or our awareness of time. So the heart of arithmetic is the sequence of numbers 1, 2, 3, 4, 5. It's a one-dimensional sequence which corresponds to our experience of time. This idea of Kant was later countered by Frege and Russell, because in the middle of the 19th century, alternatives to Euclid's system of geometry were discovered, and they are Riemann's geometry and the geometry of Nikolai Lobachevsky. These systems of geometry dropped the assumption that parallel lines will never meet, and these systems pronounced that space is curved. Now, which system of geometry is more fundamental to the absolute reality was now the deepest philosophical question of mathematical knowledge. Now arrives Einstein with his theory of relativity, and he strongly suggests that our physical space is Riemannian and not Euclidean. So, now before I conclude, I need to spare some thoughts on the idea of logic, the Juktivitthic aspect of my Thakur. I am reminded of this development in the world of mathematics, that you can build geometry upon arithmetic and algebra. So, Frege and Russell regarded arithmetic and not geometry as the foundational branch of mathematics. For them, the central question was about number. For Frege and Russell, it was crucial that arithmetic is a body of objective knowledge. They independently came to the conclusion that justice can be done to Plato's formal theory of arithmetic if mathematics in general and arithmetic in particular is just logic, strictly nothing but logic, and arithmetic can be shown to be as a branch of logic. Understood? Interesting, isn't it? According to Frege and Russell, logic is about forms, and forms really exist. In order to understand my Thakur's perspective of Juktivitthic, one needs to have a sound understanding and a good grasp of this proposition that logic and arithmetic have little difference between them. 100 years ago, logic was seen as a branch of humanities. You learnt logic in literature and not in science 100 years ago in educational institutions. Learning logic went hand in hand with studying classics at Oxford, whereas mathematics was learned if you were a scientist. Frege and Russell brought logic and mathematics together with a particular theory of numbers. This theory makes use of the notion of a class of objects, and you get to this notion through language. Now I need to end. Considering the limitations of the perceptual world, which leads towards the dissatisfaction with the perceptual world, the physical world of senses, and ultimately this leads to a higher world that is non-sensory or non-physical, and the philosopher tries to disengage himself or herself from the entire physical world. My Thakur, on the other hand, finds no need to disengage himself from the spatio-temporal world, and this is what my Thakur does, is to take a similar tradition but not put it on a metaphysical footing first and foremost. My Thakur tries to approach the ideas of both mathematics and logic through issues of cognition, through issues of epistemology, to use the philosophical idea of both the spatio-temporal world and the world of consciousness, which transcends our known world of space and time. Understood? Okay.